Welcome to this explainer. Today, we're going to completely unravel a mathematical mystery that is brilliantly disguised as a fairy tale. So I want you to picture a scene in your mind right now. Just imagine a beautiful, incredibly peaceful garden right at sunrise. And right there, in the very center of this garden, is a magical pond. Floating perfectly still on the water is a single bright pink lotus flower. But listen, this isn't just any regular flower. This magical lotus has a very specific, totally astonishing property. It doubles in number every single day. So you have one today, two tomorrow, four the next day, and so on. Let's really dive into this, because this simple little premise actually sets the stage for one of the absolute most powerful concepts in all of mathematics. To kick things off, I have a classic mind-bending riddle for you. Let's establish our timeline here. We know for an absolute fact that by day 30, this magical pond is completely 100% jam-packed with pink lotus flowers. Literally no water left to be seen. So, knowing that, on exactly which day was the pond exactly half covered? I really want you to think carefully about this for a second because, well, if you're anything like most people, your brain naturally and almost instantly wants to shout out day 15, right? I mean, it feels so logical. Half the time, half the space. We're just so incredibly used to thinking in straight, linear lines. But we have to remember the magic rule of our pond. The answer is actually day 29. Now, what's really fascinating here is how this completely shatters our standard intuition. It wasn't day 15, no way. The day right before the pond was completely full had to be the day it was half covered, simply because the flowers double every single day. If it's half full on day 29, doubling that half the very next day completely fills the entire pond on day 30. Let's see how this builds when we use a sort of rewind technique. This right here is the inverse logic of exponential growth. Basically, if we multiply by 2 when we move forward in time, we have to divide by 2 when we move backward. So think of it like this. Step 1, on day 30, it's fully covered. Step 2, rewind just one day to day 29. We divide by 2, so it's half covered. Step 3, rewind one more day to day 28. We divide by 2 again. And half of a half is 1/4. So on day 28, the pond is only 1/4 covered. It literally takes 28 days just to fill a quarter of the pond, and then only 2 more days to fill up the entire rest of it. Okay, let's keep those gears turning. I want to test your logic with a really quick follow-up riddle based on the exact same source material, just to make sure we've totally locked in this backward-moving logic. Imagine a slightly smaller magical pond. If this new pond became totally full on day 25, on which day was it half covered? You guessed it, day 24. If you got that, you are already mastering the behavior of exponential curves. You just step backward one single day because doubling half a pond today absolutely always equals a full pond tomorrow. But what does this explosion of growth actually look like if we watch it from the very beginning, instead of, working backward from the end? When we watch this timeline from the start, we start to see the rapid escalation that makes this math so incredibly powerful. Day 1, we start with just one lonely lotus. Day 2, we have 2. Day 3, we have 4. Day 4, 8. And by day 5, we already have 16 lotuses. In merely 5 days, we've gone from 1 to 16. The numbers start out so deceptively small, but they are silently building a massive, massive foundation. So, what is the crucial definition for what we are witnessing here in the pond? It's called exponential growth. It is the immense power of repeated multiplication using exponents and powers. Instead of just adding a set number of flowers every single day, the entire population is actually multiplying itself. It's basically math's version of a snowball rolling down a really steep hill, just getting bigger and faster. Now let's introduce a character from our source text named Damayanti, who decides to run some pretty cool experiments in this garden. If Damayanti leaves a lotus to grow for 5 full days, the formula is 1 times 2 to the power of 5, which gives her 32 lotuses. Let it grow for 7 full days, and that translates to 1 times 2 to the power of 6, giving her 64 lotuses. The exponent is simply telling us how many full times we are multiplying by our base number of 2. But the garden holds even more secrets. Damayanti actually discovers a second magical pond. And this beautifully illustrates how simply manipulating the base number changes absolutely everything. We are now moving from the doubling pond, which uses base 2 math, over to the tripling pond, which uses base 3 math. In this new pond, the lotus flowers don't just double every day, they triple. Let's follow Damayanti's experiment step by step. She takes 16 lotuses that she grew in the doubling pond and transfers all of them directly into the tripling pond. Just look at this incredible chain reaction over just 4 days. On day 1 in the new pond, her 16 lotuses triple to 48. On day 2, they triple again to 144. By day 3, she has 432, and by day 4, a staggering 1,296 lotuses. Now, counting 1,296 lotuses one by one would literally take forever. But look at this formula. 16 times 3 to the power of 4 equals 1,296. This equation perfectly captures the exact same growth. We start with 16, and we multiply by 3 4 separate times. It's elegant, it's efficient, and man, it saves Damayanti a whole lot of counting. All right, it's your turn again. Let's apply this new formula. What if Damayanti had started with a slightly larger batch? What if 32 lotuses are placed in the tripling pond for exactly 3 days? How would you set up that math in your head? Just remember, you know your starting number, you know your base growth rate, and you know your time.
Here is the math. 32 times 3 to the power of 3. Well, 3 to the power of 3 is 27, and 32 times 27 gives us 864 lotuses. Notice the sheer scale and speed of this growth. Starting with just a few more lotuses, 32 instead of 16, and leaving them for just 3 days results in nearly 1,000 flowers. That is the unbelievable magic of a base 3 exponent.
We can push the stakes even higher, just to see how exponents scale. What if the magical pond quadrupled the flowers every single day? That's base 4 math. If we started with just 1 flower, the equation for 5 full days of growth is simply 4 to the power of 5. 4 times 4 times 4 times 4 times 4. In just 5 days, you'd blast right past 1,000 lotuses, hitting exactly 1,024. That is the sheer, raw power of scaling the base. Okay, here is the grand finale from our source material. This is the ultimate brain teaser that mixes the magic of both ponds into one epic equation. What if Damayanti started with 1 single lotus, placed it in the tripling pond for 4 days, and then took absolutely everything that grew and moved it all into the doubling pond for another 4 days? We can break this down perfectly into a 2-part equation. The very first part is her time in the tripling pond, 3 to the power of 4. The second part is multiplying all of that by her time in the doubling pond, 2 to the power of 4. So the mixed formula is 3 to the power of 4 times 2 to the power of 4. Seriously, brace yourselves for this final result. The answer is 1,296 lotuses. One tiny flower bouncing between 2 ponds over just 8 days turns into a massive field of 1,296 lotuses. This visually highlights just how beautifully, And quite honestly, aggressively, exponents can calculate massive compound growth. Let's bring this all back to the core takeaway from our source material. Exponential growth is the power of repeated multiplication. Damiante's magical storybook pond isn't just some fairy tale. It is a perfect, highly structured illustration of the hard mathematical principles that actually govern exponents and powers. And I'll leave you with this final, provocative thought to ponder today. We've seen exactly how deceptively slow exponential growth starts, and how incredibly fast it finishes. If a single lotus can quietly conquer a massive pond in just 30 days, literally going from half full to completely overwhelmed in a single 24-hour period, what else in our world, whether it's in biology, in computer processing, or in finance, is quietly doubling right now? Thank you so much for exploring the magical pond with me in this explainer. Keep your eyes open for those exponents out in the real world.